Two great theories shook the world and shattered the earth in the first quarter of the 20th century, scattering the remains of the physics that had come before and forever, altering, changing our understanding of reality. One of these theories, relativity, was developed by a true in a true science fiction fashion by a lone genius working in a splendid isolation who left the academy only to return triumphant with profound truth in his hand. And this was, of course, Albert Einstein, or Einstein, I'm not sure how to pronounce it. Quantum physics had a more difficult birth. It was a collaborative effort involving dozens of physicists working over the course of nearly 30-40 years. Einstein was among them, but he was never their leader. The closest thing this disorganized group of people had was Niels Bohr. These revolutionaries had was Niels Bohr. And Copenhagen was the mecca of quantum physics, with nearly every big name in the field had studied there at one point, at one or another. They developed the first genuine theory of quantum physics, found the underlying logic of the periodic table of the elements, and used radioactivity to reveal the basic workings of the living cells. And it was Bohr, along with his most talented physicists and students, physicists and colleagues, Werner Heisenberg, Pauli, Max Born, Pascual Jordan, and others, who developed and championed the Copenhagen interpretation, which rapidly became the standard interpretation of mathematics, of quantum physics. What does quantum physics tell us about the world? According to the Copenhagen interpretation, this question has a very simple answer. Quantum physics tells us nothing whatsoever about the real world. The Copenhagen interpretation states that quantum physics is merely a tool for calculating the probabilities of various outcomes of experiments. According to Bohr, these two stories about the quantum world, there is no quantum world. According to Bohr, there is no quantum world. There's only an abstract quantum physical description of the world. And that description doesn't allow us to predict probabilities of quantum events. Quantum objects don't exist in the same way as everyday world around us, as Heisenberg put it. Heisenberg said that the idea of an objective real world whose smallest parts exist objectively in the same sense as stones or trees exist independently of whether or not we observe them is impossible. Results of our experiments are very real because we create them in the process of measuring them. Jordan said that that when measuring position of a subatomic particle, he said that electron is forced to a decision. We compel it to assume a definite position. Previously, it was in general neither here, neither there, neither here nor there. But we ourselves force it to exist because of our measurement. This statement sounded absurd to Albert Einstein. The theory itself is a system of delusions of exceedingly intelligent paranoia. Despite his crucial role in the development of quantum physics, Einstein couldn't stand the Copenhagen interpretation. He called it tranquilizing philosophy of religion that provides soft pillow to the true believer, and it has so damn little effect on me. Einstein demanded an interpretation of quantum physics that told a coherent story about the world, one that allowed answers to questions even when no measurement was taking place. He was exasperated with the the Copenhagen interpretation, and he called it an epistemology-soaked orgy. Well, Einstein's objections went completely unheard, part because of John von Neumann, that no such theory was possible. Von Neumann was arguably the greatest mathematical genius alive at the time. He had taught himself calculus at the age of 8, published his first paper on advanced mathematics at the age of 19, and earned his PhD at the age of 22. He played a crucial role in building the atomic bomb, and he was one of the founding fathers of computer science. He was also fluent in 7 languages. His colleagues half-jokingly said that von Neumann could prove anything, and anything he proved was correct. Von Neumann published his proof as part of his textbook on quantum physics in 1932. There is no evidence that Einstein was even aware of this proof, but many other physicists in the world, it did exist. And for many other physicists, merely the idea of proof from von Neumann is proof enough. And it was enough to settle the debate. The people who followed Bohr did not clarify the arguments, but the whole debate was always settled by von Neumann. The mere name of von Neumann and the proof even silenced all the objectors. There was at least one person who noticed one problem with the von Neumann proof shortly after it was published. It was Grete Hermann. Grete Hermann, I'm not sure how to pronounce it. She was a German mathematician and philosopher, and she published a paper in 1935 criticizing von Neumann's proof. Hermann pointed out that von Neumann failed to justify a crucial step, and thus the whole proof was flawed. But nobody listened to her, partly because she wasn't part of the community and she was outside of the community of physics, and of course she was a woman. So despite the flaw of von Neumann's proof, Copenhagen interpretation remained totally dominant. Einstein was painted as an old man out of touch from the real world, and questioning the Copenhagen interpretation became tantamount to questioning the quantum physics itself.